friends, today we will be discussing about solar cell. Nowadays everyone is talking about green energy. And when we are coming to this green energy, definitely one thing comes to our mind, that is solar energy, and the solar energy is used in form of solar cells to generate powers. All of you must have seen these types of solar cells in your near vicinity, right? Here these are the street lights which are using solar cells. Are these the solar cells, these big ones? No, these are solar panels, okay? And these are made up of solar cells. So today we will be discussing about that solar cell. Basically those solar panels are made up of solar cells which are very small in size. So this is a picture of a single solar cell. The power generated by this single solar cell is very less, and we generally need high powers, right? And to enhance the power generated, generally what happens, people are using these solar cells in rows and columns. Initially there will be some arrangement like this. Here this small one are solar cells, they are arranged over a panel, and this is known as a solar module. Generally the number of solar cells used to develop a solar module is either 36, 72 like that. So here in this solar module, if you can see, there are 36 solar cells. Now if one wants to increase the power further, then this type of solar cells can be arranged in rows and columns. So when solar modules are arranged in rows, they are known as solar panel. And if these solar panels are again multiplied in number, that will lead to solar array, or which is also known as photovoltaic system. And this is what I have shown you in the beginning, right? So we came to know that what we are using is not a single solar cell, but it is a solar array or PV system which is made up of solar cells. And this arrangement is made to enhance the power generated, because the power generated by a single solar is very less, and hence they are grouped together in solar modules, panels and array or PV systems. So these solar array or PV systems, they are made up of solar cells, and this is a single solar cell. Today we will be discussing about this solar cell. Basically the solar cells, which are also known as photovoltaic cells, these are semiconductor devices that convert the light energy into electric power through photovoltaic effect. Thus, in case of a solar cell, we are getting electric power from light energy, and that effect through which we are converting the light energy into electric power is known as photovoltaic effect. So the photovoltaic effect is nothing but appearance of forward voltage across an illuminated junction. So basically this is a PN junction, which when illuminated with light energy, then we will be getting some voltage across the solar cell. In case of a solar cell, the power is being delivered to an external circuit by illuminating a PN junction. This solar cell is basically a PN junction. So when we are illuminating that PN junction, we are getting electric powers, and that power is delivered to some external circuit or device to operate those devices, right? It is a PN junction with large surface area and very thin upper layer which is facing towards sun. The surface area is very large. Further, this is a PN junction, means we are having two layers. One will be p type, one will be n type. Okay, so these two layers are there. Further, if this p type is facing towards the sunlight, then this should be made very narrow as compared to n type. If n type is facing towards the sun, then this should be made narrow. Okay, so that is what written over here, very thin upper layer which is facing towards sun. Now coming to the structure of solar cell. This is the structure over here. This yellow one over here, this is the p type, and this blue one here is n type, and this brown color over here, that is the junction between n type and p type. So this is the p-n junction. So basically this is a p-n junction over which the sunlight will fall and will be getting electric power. And here you can see this n layer is thinner as compared to the p layer. That means here this n side is facing towards sun, and the layer which is facing towards the sun, over that layer will be putting some anti-reflecting material. So this purple one over here is the anti-reflecting material. So by coating this, we are making sure that whatever the sunlight is being incident on this, all will be absorbed into the device, and very less of the incident light should be reflected back. Okay, that's what we are putting this anti-reflecting coating. And over that anti-reflecting coating, we are having these thin finger-like structures which are made up of metals, and they are connected together. Through this, we will be taking the connection to the device, external device. Okay. So these are the metal fingers over the top layer, and here at the bottom also we are having a metal contact. So if this is a solar cell, the metal contacts through which we can connect a device to this cell is this one. This is the metal contact on the N side, and this red one is a metal contact on P side. So this is the structure of solar cell. Let us move to the operation of solar cell. So just I have taken the cross sectional view. We had this P type, N type. This is the junction over here, and this is our anti-reflective coating. This is the metal contact coming from the N side, and this red one is the metal contact coming from P side. As I have already told, this upper layer is made very small so that whenever light is being incident on this solar cell, maximum light they will cross this region and enter to the depletion layer, where they will be generating the electron hole pairs. So when light is being incident on this solar cell, most of the incident light passes into the depletion region, and electron hole pairs are generated in this region. Okay. So because of this incident light, we are getting electron hole pairs in the depletion region. If you remember, in the depletion region, we are having one barrier potential which is developed by the uncovered ions in the depletion layer, right? And what is the polarity of that barrier potential? On the N side, we are having uncovered positive ions, so this side is positive, and on the P side we are having uncovered negative ions, because of which we are getting negative barrier potential at the P side of the junction, right? So this is the polarity of the barrier potential. Towards N side it is positive, towards P side it is negative, and because of this barrier potential, whenever these electron hole pairs are generated, they will start moving either towards P side or N side depending on the polarity. So this side is positive, that means electrons will move towards N side, and this side is negative, that means the holes will move towards P side. So because of the electric field which was developed due to the barrier potential, the electron hole pairs generated, they are getting separated from each other. The electrons will move towards N side and the holes will move towards the P side of the solar cell, right? So this is the movement. So if electrons are moving towards the N side, that means this side will be more electron negative. So this metal will be negative in polarity. Similarly, if these holes are coming towards P side, this metal contact will be positive in potential. So electrons move towards N side and hole move towards P side, and because of these carrier movements, we are getting negative potential at the N side and positive potential at the P side. So negative on N side and positive on P side. Thus, there is a potential difference between these two ends, and hence a potential difference develops across the solar cell, and this is the potential or the power which will be used to operate some electrical devices, right? So this is what we have seen. This is P side, N side, and we have seen that on the P side we are getting positive potential and here we are getting negative potential. So there is a potential difference between this end and this end. Further, this potential difference which is developed across the solar cell, that depends on the intensity of the light which is being incident on the solar cell. So the potential difference developed across the solar cell is proportional to the intensity of incident light. If the intensity will be more, we will be getting more potential difference across the device. If it is less, that will give less potential difference. Further, it also varies depending on the material which is used to form this PN junction, and depending on the material used, it varies between 0.25 volt to 1 volt. For silicon it is around 0.5 volt, but for germanium it is coming around 1 volt. So the potential difference generated by a solar cell is around 0.5 to 1 volt, and definitely we need a higher voltage as compared to this. That is why we are using different solar panels instead of using a single solar cell. Coming to the power conversion efficiency, the power conversion efficiency for a single crystalline solar cell lies between 10% to 30%. That again varies depending on the material used to construct the solar cell. There is a potential difference between these two ends, right? So if we will connect some device across this solar cell, that device will run because of this potential difference. So now we will be connecting some load. Let the resistance of that load is RL. This load may be any electrical appliance like your fan, mobile phone, whatever it can be, and let the resistance of that electrical device which is connected to the solar cell is RL. Now when we are connecting this electrical device over here, this side is positive and this side is negative, so a current will flow through the device, right? So this is the direction of the current flow. Now if the potential drop across the device is VL, then the power consumed by this electrical appliance is equals to IVL, where PL is the power delivered to this electrical appliance, I is the current flowing through the device, and VL is the potential across this electrical device, right? This shows that this electrical device, it is taking a power PL from the solar cell. That means this solar cell is delivering power to the electrical device over here. Okay. Thus, power is delivered to a device when connected across the solar cell. So this is the basic about a solar cell. In the next class, we will see the VI characteristics of solar cell and the fill factor, advantages and disadvantages of a solar cell. Today we'll stop here. Thank you all. If you like the content of the video, please press the like button and share the link with your friends. Further, don't forget to subscribe to my channel to get the notifications whenever I am uploading new videos. Thank you all.